Hey YouTube, Stockkill here. And grains of sand are incredibly tiny. In fact, they're some of the smallest objects that the naked human eye can actually discern, of course. And the speed of light is very quick. It's the fastest possible speed in the universe. What if you combine these two? What if a grain of sand were to hit the Earth at the speed of light? Before you can answer that, you need to take off the simulation that you were using to view the event and start yelling at the person who designed the simulation, because no objects that have mass are able to travel faster than the speed of light. But once you calm down, they say, alright, what about at 99.999999999% the speed of light? What happens then? Well, that is actually something we can work with. Now, you need to first understand the mass of a grain of sand. It's probably going to be around 0.01 grams. And how do we get the formula for kinetic energy? It's not the normal formula you may have learnt in school, because this is so close to the speed of light that relativistic physics takes over, and that means that we use a different formula, which is gamma minus 1, where gamma is the Lorentz factor, which is what I'll describe in a second, times mass times the speed of light squared. So, what is the Lorentz factor? Well, as you get closer to the speed of light, the relativistic physics is used more often to work out the energy released, and the Lorentz formula is used to find this. The Lorentz formula is found by the formula 1 over root 1 divided by velocity squared. When you plug these numbers in, you get roughly 5.48 times 10 to the 12 joules of energy when it hits the Earth. So how much is 5.48 times 10 to the 12 joules of energy? Would it be enough to destroy the planet? Would it be enough to end human civilization as we know it? It would be equivalent to 1,310 tons of TNT exploding at once, which, I mean, it's more than nothing. But every single nuclear bomb, basically, that has ever been made makes that look tiny. Like, for example, the atomic bomb dropped on Nagasaki is over 20 times more powerful than that. And that was an atomic bomb, and just think about comparing it to a modern-day hydrogen bomb, which, I mean, it shouldn't be that surprising. I mean, it has a mass of 0.01 grams, but you might just expect a little bit more from travelling at the speed of light. But anyway, the thing is, you wouldn't actually see it explode at the speed of light on Earth and make a crater here, because it would be vaporized basically instantly upon entering the atmosphere, like the Chelyabinsk meteor. However, unlike the Chelyabinsk meteor, it won't explode with 400 kilotons of energy, and so it will be just a tiny puff a couple hundred kilometers above the Earth's surface, and we barely even notice it.